Hello, my name is Ben Lewis. Street number is 200461210. I'm going through systems and drives autonomous car assignment. I'm going to go through what I've managed to achieve. So for the sensors, got the ultrasonic sensors to the left, center, and right. Car slows down so in front of it. Servo steers when the input value into the servo monitor. Light sensor activates the LEDs when the light level is too low and switches them on when there's not enough. When it switches them off and the light level is too high. Slave Arduino specifies from magnetometer to the master Arduino. Potentiometer changes the values and the character outputs. Slave Arduino simulate camera changes the value depending on which button is pressed. Simulates camera. Button switch changes character value, gives crash indication in serial monitor. I didn't manage to get it to change the speed of the motor. For LabView, clearly displays all the sensors. Fuzzy logic control the speed and direction of the vehicle depending on the character inputs from the ultrasonic sensors and heading read values. That's right, and then manual override for the inputs manually that can change the values manually for dials and meters. Output strings for the servo motor that you get at the end to be put back into tinkercad, and I had to go at the MATLAB neural network. It's just a quick schematic. Got all my sensors, collision button, LEDs for transistor connected to the master. All them connect to the master Arduino. Slave Arduino connects to the potentiometer, sends signals back to that. Slave Arduino connects to the camera, again sends back to the master Arduino, 9-volt batteries, DC motor, and the camera. So I'm just going to quickly go through my LabView. So here you got your constants and what order you input them in. You got your number of characters, and it is not seven characters. Number of characters is not seven, and there's an error. So for when it's manual, you're controlling the sensors yourself, you're changing the values, moving the dials, and that. And then when it's automatic, it's doing these calculations automatically and then you get the values you get are then put into these sensors, head and then the readings as well. Depending on the light level you put, the headlights turn on, what collision you set depending on it. So fuzzy control, you got your speed and you got direction. I would show it, but it's taking too long to. I'll go over time. Speed, servo string. So you're calculating what outputs you get. So this is for left, center, and heading. To the left, right, and heading goes into the fuzzy. Get a value in stereo meter. Then you're converting it back into a language that tinkercad to work can read. So it's going to be letters using ASCII language. Same here, converting it back into letters for the motor output. So you're putting them back into the tinkercad. So I'm just going to go through tinkercad right now. So you got your servo, you got your left, your center, your right, LED, bumper, potentiometer, slave Arduinos, camera, DC motor, and your 9-volt battery. So you got all your outputs. So let's say you have ZZ there. It's going to it will move your servo. Let's change this potentiometer. Right now it's on A, so it's going to go there. So your servo moved, your clock, and your speed changed to 255. So right now, this is the values you get. So let's make this close. Let's make it like there. Let's make this one far away. And let's make this one close as well. So you change your values. It goes to EUE. So your second, your third, and your fourth characters are each like center left, center right, respectively. For your LED, the fifth value is the light sensor. So that goes back to A. So LED on. For your 6, it's your compass values. So let's put that to here. Let's say YO. Put it to here. VA. Oh no, VV. Sorry. And then your final one is for your bumper. So it says crash, and you got B. And then and then your first letter is for your camera. So let's hold this down. Change this from CT. Change this on. And if I input back into here, let's say something in between, let's just go So it changes your servo and it changes your value. Let's go CC. Again, changes your servo. Okay, so now it's going to go through my code. Let's just go. Oh no, I'll go through my I'll go through my LabView right now. So let's just run it. So manual, you're putting in your sensor. So let's say you got something really close to your speed's going to be very, very small. That's actually 0 right now, but as you get further away, it speeds up, maximum 411. But if there's something touching it, you're going to be going backwards. Let's say there's something like relatively close. There's nothing to your left though, so you're going to be going left, and there's something to your right, so you're going to be going hard left. Let's say there's nothing to your right, you're going to be going soft left, soft right, because that's the best option to go. Let's change that. So yeah, you got your left, but there's something in your center. Let's go with that. So you're going to be going. You're going to be wanting, yeah. As you can see, it also changes the speed. Speed depends on your center. So proximity warning as well. You see that? So it's too close. And then I got bumper, collision, and then you got your light level. So when it's headlights are not anymore because the light level's too high. Now it's on. Manual reading. Let's change that to automatic. So you got C, that's camera. So you got something far to your left, relatively close. So far to your something far away on your left, relatively close on your right. No, it is close on your right, on your center, and far left on your right. Speed is 0. So let's change this center to something like X. So now you're going to get a bigger speed. You're going to get. I change it to S. You're going to get a bigger speed. It's going to be going left. So let's just change that back to. Let's change that to S. To A to D X A. So there's nothing in your sensor, so you're going to be going as fast as possible. Right is A. You got your light sensor at A, so let's change that to L. Yeah, that's good. And then your heading, let's change that to D. Yeah, and then your final one, let's change that to B. You got a collision there. And then you got here's your area of character input. So you also get your speed, your servo output. So let's change that to A, or even SDS. But that's too many. I forgot to do that. So again, these motor outputs. Let's go back to this. I'll now go through my code. So we're just going to quickly go through my code. So define LED, preprocessor directives. There you go. Defining which pins are at. This is connected. That's all to do with this. Defining characters. This is the order they come out. But just defining them there. More defining Boolean variables, state the direction. Another preprocessor directive. These are magnometer variables defined again. Bumper variable. Input for steering variables and all that again. Preprocessor directive defining which pin the servo pin is at, and servo defining the servo, and the reference angle. Distance to the ultrasonic sensor at the start. So open and then void setup. Open serial with communications. Setting digital pins for each variable output or input. So motor pins, LED, bumper, ultrasonic, and then here we are connecting the servo to the servo pin. So what the values and all that. So what you get in the pin will then affect the servo. The reference angle, void loop, reading the data in the input and input steering variables. So your first input letter is for your steering, your second input letter is for your speed. This is mapping them to 65 is A, 90 is Z. So it's changing its layer. It's changing them back into letters. Oh, it's changing. Yeah, you're getting like you're getting it. So it's -60 at Z type thing. Again, just the same thing. Check the distance is correct. Read in the print light sensor. Switch on the LEDs if requirements met. Converting the light level, reading to character using the ASCII language. Function, read to read the compass, yeah, just defining functions as well. So this is button state for the crash. So 65 A, B, A, 65 is for the letter A, 66 is for B. So button state high, calculating converting the distance from each ultrasonic sensor. And this is for the left, so it's calculating distance and converting it into letters. So for the output, so that's for the left, the center, and the right. This is all the stuff you get here, where it's converting it, it's mapping it. So then this is the order that comes out, and then this is so it's anti-clockwise. So this is this stuff here, and then clockwise. We had some stuff of it earlier. Reading the magnometer, or printing the magnometer, and then getting the values, converting the values back into converting the values into characters here, and then stopping, shows the speed and serial monitor. Set the condition for when the bumper is in collision and what the message prints when the condition is met. Is that when you put B, when you hold the bumper down, it goes to B. This is what shows. And then slave Arduino. This is slave Arduino from 3. So again, it's just defining stuff, variables, open comms, transmit the values to master Arduino, which is this one, and then it's doing some calculations here as well. Again, preprocessor directives, defining things, and then camera starting up, transmitting the values for back to the master Arduino. This is for your camera, so it's like C, B, A, what button does depending on which button is pressed. This is my MATLAB, so there's no letter frees in here because of the stuff I did. I'll just slowly scroll through that. It's neural network. It's the learning curve and that.